Hi all. So this is part 9, I think, of rational exponents. It's a long section, it really is. You want to do a traditional class, it goes forever. Well, it's just long. I was about to say it drives a person to drink, but if you don't drink, it'll drive you crazy. But I think this is the last one we're looking at, and then I'll move on to a different unit. So let's look at using rational exponents to simplify the 4th root of x to the 6th over the 5th root of x to the 6th. There's a couple ways to do this. I'll show you the way that they probably show you in the book. That's mathematically correct. And then I'll show you a different way that's kind of cool. So what we're looking at here, first of all, let's rewrite these things so we have rational exponents. So I'm going to rewrite this x to the 6th to the 4th rooted as x to the 6 over 4. And then this guy, I'm going to rewrite as, from the 5th root of x to the 6th, I'm going to rewrite that as x to the 6 over 5. Now, it could reduce to 6 over 4. Sure, I'll reduce that. X to the, 3/2 over x to the 6/5. Now, I've got like bases getting divided, so we need to subtract the exponents. If you're not sure which one's bigger to show which side of the fraction part it's going to be on, then default it to the numerator. So like bases getting divided, I'm going to subtract the exponents. So we're looking at x to the 3/2 minus 6/5. We're going to need a common denominator, which is 10. So I'm going to multiply top and bottom here by a 10. Excuse me, not a 10, a 5 for the first fraction. The second fraction, I'll multiply top and bottom by a 2. And that'll put us at x to the 15 over 10 minus 12 over 10. So I guess I had it right. 15 is bigger than a 12, so it's going to come out positive. So this is the x to the 3 over 10. Now it started as a radical, so I'm going to finish it as a radical. So we're looking at the 10th root of x cubed. Okay? And like I said, there's another way I could have done this. So let's say another way. This is crazy math, I'm calling it. So we're looking at the 4th root of x to the 6th over the 5th root of x to the 6th. So if you saw my part 8 video, I showed you a little bit of a shortcut when you're working with the product rule for exponents, okay? So, with the quotient rule, it's kind of similar. These indices are going to multiply them together. That's going to be 20. So we're talking about the 20th root at the moment of x to the 6th raised to the 5th power which means you're really going to be multiplying those powers, right? And then we're going to subtract, I'm getting ahead of myself. Let's make this easier on myself. It's going to be x to the 6 times the 5, and since we're using the quotient rule here, we're going to subtract this 6 in this exponent here times the index of 4. In other words, we're going to be talking about the 20th root of x to the 30th, right? 6 times 5 is 30, minus the 6 times 4, which is 24. That's the 20th root of x to the 6th. But then you might be thinking, okay, I know I tried this in part 8, it worked out, I got the same answer here as I did here, but wait a minute, I didn't get the same answer this time. Okay, here's the caveat here. If you use this little shortcut that I just did, check and make sure that your index and whatever your powers are in here are not multiples of the same some number. In this case, they're both even, so I know they're both divisible by a 2. So I'm going to divide by 6 by 2. I get 3. I divide 20 by 2, and I get 10. Well, now, look at that. The 10th root of x cubed. So there's a couple ways to do these problems. I hope I'm kind of muddling my way through that shortcut on the second one. I'm a little bit tongue-tied. But hopefully you get the idea about how to use the shortcut when using the quotient rule for rational exponents as well.